Welcome back to part 3 of the Backspace Academy lab on highly available and fault-tolerant architecture for web applications inside of VPC. In this lesson we're going to look at creating public and private subnets in a second availability zone. And once we've done that, we're also going to look at creating custom access control lists for our public subnets and our private subnets. So the first thing we're going to do is jump into the VPC console, and then we're going to go to subnets and create a subnet. So we'll call this private subnet number 2. We'll make sure that we select the correct VPC, the Backspace-Lab VPC that we've created, and for our availability zone we're going to check US East 1B, and our CIDR block will be 10.0.3.0/24. Once we've done that, we'll create our new subnet. And there you can see our new private subnet number 2. So we're going to create another subnet now. So we're going to call this one public subnet number 2. And again, make sure we select the correct VPC. And we'll launch this again into US East 1B. We'll create this in US to East 1B. And our CIDR block is going to be 10.0.2.0/24. And we'll create that as well. So we'll just click on our private subnet number 2 and have a look at that. So click on the route table tab, and we can see there. So we've got a local route that's created. We've also got our VPC endpoints there, which is fine, and we've got our outbound traffic is pointing to the Elastic Network interface of the NAT instance. So that's fine there. So then let's have a look at our public subnet number 2, and we can see here we've got exactly the same route. So that's not correct for us. So we don't want in our public subnet our traffic to be going through our NAT instance. Okay, we want that to be going through our internet gateway. So the reason that's happened is because we haven't explicitly associated a route table with our public subnet. Okay, and so implicitly the VPC main route table has been associated to it. So in our private subnet, that's fine. So we want the main VPC route table to be assigned to that. But in our public subnet, we want our public route table to be assigned to that. So we can look at changing that. So we'll go into our public subnet here again. So we can just change that by clicking on edit, and then we'll select our other route table there, and we can see there that it's instantly changed to pointing to that internet gateway. So we'll save that. And so we have now created our public subnet number 2 with the internet gateway, the route to the internet gateway for that. Okay, so now that we've created our public and private subnets, we'll have a look at the network access control list here. So we can see that it's allowing all traffic in, all traffic out. So that's a little bit too broad for us. So we'll look at tightening that up now by creating two network access control lists for private and public. So go to network access control list page over here and create network access control list. So we're going to call this public NACL, and we'll make sure that we select the correct Backspace-Lab VPC, and then we'll click on create. Okay, so just fast forwarding there, we've clicked on our inbound rules, and now we're just going to put those in. So we've got the first rule is going to be for port 80 access from anywhere. The same for port 443. And then we're going to have here port 22 access. So that's going to be for our personal access through to these instances that are located in the public subnet. So you would normally in here, you would, for the port range, you would select my IP, but for here we'll just leave it as 00 anywhere. But in a production environment, of course, you would put your IP in there. And again, rule 130 is going to be for a custom rule for the ephemeral port range 1024 through to 65535. Now that is going to be for requests that are coming in from the elastic load balancer. So this is very important to have this, because if you don't have this, you're going to be having problems with your ELB health checks, and they'll be failing persistently. So very important you have that in there for your ELB, and that's down there, source anywhere. So we just save on that. Oops, I'll just get rid of that last one that's empty there, and we'll save that. So now we do the same for our outbound rules. Click on edit, and we'll fill that out. Okay, so just fast forwarding there, we've completed our outbound rules. So we've got here the first rule, rule 100, is going to be for the port range for port 80, and the next one's going to be for port 443, destination anywhere. So again, network ACLs are stateless, so we need to create outbound rules for that return traffic for port 80 and port 443. Likewise, again, we've got there port 22, so the return traffic going back to the private subnet for our Bastion hosts. So that's there with the destination of the private subnets. And so we've got that replicated down here in rule 150 for port 22. The next one there is going to be a custom rule again for the port range 1024 through to 65535. Return traffic there for the elastic load balancer. Very important we have that, otherwise we're going to be failing health checks. So there we go, MySQL return traffic again coming from the private subnet. And the next two are going to be for return traffic again for the Bastion host, and the MySQL RDS instances are going to the second private subnet. So we'll just save that. So now that we've created our public network access control list, we're going to associate that with our public subnet. So we click on subnet associations, and we'll click on edit, and it'll come up with a list of our subnets that are located in our backspace-lab VPC. So we obviously want to select our two public subnets. So public subnet number 1 and public subnet number 2, and then we click on save. By doing that there, now we have associated the network access control list, our public NACL, to our public subnets. So now we repeat the process for our private network access control list. So this will be called private NACL, and we select the correct VPC again and create. And again, we put our inbound rules in there. Okay, so just fast forwarding there, we've got the first rule is going to be for our MySQL access on the port 3306, and that's going to be for our or requests to our RDS instances coming from our web servers located in the public subnets. The next one we're going to have there is port 22 SSH, and that's going to be for any Bastion hosts that we launch inside the public subnets. The next two there are going to be the same thing again for MySQL and SSH for the Bastion hosts, and that's for the the range 10.0.2.0.24, and that's our public subnet number 2. So these two here are for public subnet number 1, which is 10.0.0.0/24, and then the next two here are going to be for public subnet number 2. The last rule there is going to be a custom one for the ephemeral port range of 32.768 to 61,000, and that is going to be for requests or for inbound traffic coming from the NAT instance. So we just click on save for that now. So we do the same for our outbound rules. So we click on the outbound rules tab and we edit that. So the first rule there is going to be for port 80 access, destination everywhere. Again, port 443, destination everywhere. Then we've got a custom TCP rule for the ephemeral port range 32768 through to 61,000. Now that is going to be for return traffic coming from our RDS instances. So again, because network access control lists are stateless, you must create inbound and outbound rules. So we're going to be getting requests from our web servers through to our RDS instances. So to allow those RDS instances to reply, we need to have an outbound rule. So that's what we've got here, 32768 to 761,000 port range, and destination being public subnet number 1, which is 10.0.0.0/24, going through to public subnet number 2, which is 10.0.2.0/24, and we'll save that. Oops, we'll get rid of that one and we'll save that. So again, the next thing we need to do is to associate the private network access control list to our private subnet. So again, go on subnet associations, click on edit, and we select our two private subnets this time. So private subnet number 1, private subnet number 2, and we click on save. Okay, so that's all for this lesson. So in our next lesson, we'll be looking at creating an elastic load balancer to front our internet-facing traffic, and then we're also going to look at creating an auto-scaling group to launch our web server instances and have our traffic distributed across those instances with our elastic load balancer. I'll see you in the next lesson.